And welcome back to the Workshop Robots. Today we are going to look at one of my only remaining actual enterprise servers in the lab, an R720xd. This is my TrueNAS Scale storage device and has all of my SSD storage in it, my NVMe storage in it. It has a 20 gigabit connection to my network. It is old and a power sucker, but it also has PCIe slots available. Normally I run a P2000 in here and a 1660 only for my Plex services on this. All it is my storage server and Plex, and that's it. But today I thought we would dig out some other junk, which is some Tesla M40s that I had around from when I first started getting into AI and LLMs, and shove them in this server. So this server is already customized. Warning, there is carnage incoming. We are going to take the cover, we're going to cut it up so that we can put the cover back on, tape it up so we don't get all cut up, and then we're going to take a look at these Tesla M40s, which are going on eBay anywhere from, like 90 bucks to 150 bucks. We've seen some up here around 200, but that's just ridiculous, guys. These are 24 gigabyte cards. These cards are from 2015, much like this server that we're going to shove them in. They have 24 gigabytes of GDDR5 memory, 384-bit bus, a bandwidth of 288 gigabits per second. These things will suck down around 250 watts each. They are part of the Maxwell architecture, so one of the oldest cards with CUDA cores that are still supported these days. So here's a little mount that I'm making, 3D printed, because we got to get these things cooled by a fan. This is all sealed off. We put the mount in. This is a high static pressure, high RPM fan that we are putting in there. You have to push a lot of air through these cards. Here's another look at the mount that's all up. Yeah, look at all that pretty green. Remember, you're going to need a lot of power for this, so you're going to need the Dell R720 Ys plus some splitters. Here's the P2000 and the two M40s in there. You can see this is my TrueNAS Scale. It's got two E5 2690s at 3 gigahertz, about 384 gigabytes of VRAM. We have a virtual machine that we are passing through those two specific M40 cards to. The P2000 is still saved for running my Plex server. Yep, so there's 3 GPUs attached to this, along with all of my storage. I have local AI all set up on this because we just added it as another Kubernetes node, that virtual machine, into my Kubernetes cluster. You can see the two M40s up there. Let's get the Grafana and Prometheus off to the right hand side, all set up to only look at those two M40s. These are metrics that will tell us the power usage, the GPU utilization, and the total VRAM usage. Let's go ahead and start out with the iQ4 version of Llama 3.3 70B. So this is a pretty big model. It should fill up these two M40 cards. We'll run it through our normal tests. Let me get the name in for the report. Dual M40s, Llama 3 70B should be good. We're going to ask this if it can write us a GitHub action that basically builds out a Docker file, blah, 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 blah. It's basically roughly 100 in token, depending on the model that you're using and the tokenizer that is in that model. Question, and we're going to run that test 20 times just to get some averages of speed and different numbers, and then we will show all the graphs at the end after we run through a few different models just so that you guys can get an idea. Let's go ahead and get this started. This is Llama 3.3 70B at an iQ4 quant, I think. That's close to a KM4. Let's watch this get loaded up. Let's get these windows adjusted up so you can see just a little bit better while this model loads up. Remember, this is DDR3 memory in the server, so it's going to move a little bit slower than what we would expect from any of the newer hardware that you guys normally see on this channel. But these are still useful cards, can be used for many things, and I'll show you that through this video. I think we'll even get into some text to video or text to image generation through QwQ at the end after we run through some speed checks like we normally do. So here we go. This is what Llama 3.3 70B feels like on a pair of Nvidia Tesla M40s. The graphs on the right will take a second to catch up. They do lag a bit behind. I'll pull NVTop over here in just a bit so that you guys can see this. But this is what it feels like. Remember, I talk a lot about perception. Everyone thinks about like major hardware and cost and the speed that you're getting out of it, but it's all perceptive about what you expect back. So these are $200 worth of GPUs, 48 gigabytes of VRAM total running Llama 3 70B. And frankly, it is not too terrible. This could still be useful. You just have to be patient with it. And we can see we're using about 43.8 gigabytes of VRAM in total as those charts off to the right start to get caught up. I'll let you guys feel this out. We'll get a speed here at the end once it finishes, which looks to be about in the maybe 2 to 3 token range. But we'll figure that out once it finishes up here. And then we'll kick it into fast forward mode and we'll come back and we'll do Qwen QwQ preview 32B and see how that one goes. Also, Llama 3.3 is a pretty good model, especially if you can use much more of the higher quants, which I do on some of my other lab machines. And while this starts out, let's go ahead and talk about what are my plans for using these 10-year-old Tesla M40s. Well, frankly, I need a backup inference server that can run multiple small models while I do maintenance on my other servers and my other GPUs. And there's a lot of stuff that I do in the background that doesn't necessarily need full speed inference. So these can run multiple models with that type of VRAM at decent speed for a backup when I need to swap things over in my lab. And yes, I know that sounds crazy, but I have these GPUs. I have this old server. It's my last one. Eventually I'm going to decommission it too, but for now, let's go ahead and use it. It does have dual 1100 watt power supplies in it, so it has plenty of power to give. People will say that that's too much power to suck on those PCI expansion boards. Well, you know, if it blows up, but I don't think so. Especially for normal inference when we're just bouncing around. And you can see the power usage up there, averaging about 160 watts across the board of both of those. So not doing too terrible at all. If you really work these cards though, they will easily hit that 250 watt limit that they have. I've seen them go above. Also, these cards are pretty hot, so again, you have to put some serious fans on them. They are meant to be inside servers with high pressure fans to cool them down. It looks like Llama 3.3 is doing a great job of explaining exactly the GitHub action code that it wrote above. Comes back at about 2.45 tokens per second. Let's hop into fast forward mode and we'll come back for the next one. Alright, and after 20 tests, it settled down to just over 2 tokens per second. Let's go ahead and produce this report. Don't worry, I'll show you guys all the graphs put together at the end when we go through a few more models, just so that we get some comparison. And then we'll reset this up to start to do the Qwen QwQ 32 preview at a Q8 quant. And we'll work on that. Alright, let's go ahead and get this all reset up. Cycling the pod out, clearing out the memory, you can see on the right hand side. By the way, I brought an NV top down there at the bottom right. This is more live metrics that you guys can see over there. Let's go ahead and let this finish up restarting. And then we'll swap it over to the QwQ 32B preview model. Let me just go down to it. This is at a Q8 quant. Go down and change the report name down here so we can find it later on. At 32B and a Q8, this is also a fairly big model, so I expect it to fill up both of those cards pretty darn well. Let's go ahead and get this started off. Same test. We'll run 20 again so that we have all the comparison at the end. Go ahead and let this load up. And again, letting you guys feel the initial load up time of the model. It takes a while, especially when it's these bigger models, to transfer through RAM and into the GPU VRAM. Let me know down below, what would you use these two Tesla M40s for? Or do you guys just think that they're so trash and too slow when they're really not all that slow if you just temper your expectations? Still loading up QwQ. Again, gotta have your patience with this older hardware. You can see it transferring over to the VRAM now. All the host memory dropping off, and there it should start responding to us. So this is Qwen QwQ 32B preview at a Q8 quant. I've also found that this model is pretty fun to work with. It's definitely interesting to watch it do its work if you pay attention, but it's actually quite accurate and pretty amazing at what it can pull off too. We can see here it feels just a bit faster than what Llama 3.3 70B did, as expected, with it having less parameters to work off of. This, to me, feels about 4 to 5 tokens per second, and totally usable, and this is at a Q8 quant. To some people this might feel pretty slow, but let's be honest, no human is really working even at this speed at all. If you are, good for you, but you should probably slow down or you're gonna like burn out real fast. Still looking pretty good over there. And again, looks like we're using someplace in the range of about 43 gigabytes, 42.9 gigabytes of VRAM in between the two cards. One thing to note about these Tesla M40s is that they're not true 24 gigabyte cards. They basically, as you can see over there in NV Top, cap out about 22.5 gigs each. So don't feel like you get robbed. It just is the way it is. Looking pretty good, being very specific about what you need to do outside of the code that it just wrote, which is great. Telling you the steps that you need to commit and push it up to GitHub to get it to work. Also great. Going through the explanation, nice. How much these different open source models have evolved over the last year, year and a half, 2 years is just mind-blowing. What do you guys think? Tell me down below. What do you think about the amazing technological advances different open source AI models are making these days? Let's let this finish off. We'll get a first speed off of it, and then we'll kick it into fast forward mode. Come back, and then let's run a Mistral 7B. That should be pretty quick on these. And the first one back at 4.89. And settling out at about 3.86. Let's go ahead and produce that report and get this all reset up. And let's go ahead and try a much smaller model, which is Mistral 0.37B. This is what we use for our leaderboard test that we have for the last several months at least. Let's go ahead and get that all set up. Need to go ahead and cycle the pod so that we clear out all the logs and start fresh. You'll see the memory drop off. And we'll go ahead and get this reset up. Let's run Mistral 7B at a Q8 quant also. So a really high level quant of Mistral 7B. Now this is a small enough model that you could easily run it on one of these Teslas, but just for the sakes of it, we'll keep it going on both of them so it'll be split in between the cards. Alright, okay. Let's go ahead and run our typical 20 tests and get this started. This one should load up quite a bit quicker just because it is a much smaller model than either Llama 3.3 70B or the Qwen QwQ 32B. This is only a 7 billion parameter model. Looks to be just cruising right on by. Let's go ahead and get a first evaluation tokens per second off of this one. And then we'll zip into fast forward, come back, and then do one more model before we look at the charts. 20 tokens per second. And it's settling out to about 16 tokens per second. Let's get that report generated. We'll go ahead and cycle the pod and reset up to do, let's say Gemma 227B. That's a bit of a bigger model in between this and the QwQ model as far as parameters, since it's 27 billion. We'll set it at about a 65K context though, so that it eats up a little bit more VRAM, and we'll see where Gemma 2 comes out at. Let's go ahead and get this all started off. Cycle in the pod, let it restart here. And Gemma 27B. Change the report name down here just so that we can find it after this test is over. And then let's go ahead and get this test started off. We can see it loading up over there. I think this will be our final inference test, and then we'll put these all in a chart together. Take a look at the different graphs, and then if we have time where I feel like it, I'll satisfy everyone who's always asked me to go do some, stable diffusion work, and we'll go take a look at maybe doing some text to image or text to video work on these 24 gig M40s from 2015 and see how they actually perform. All right, this is the first test running on Gemma 2 27B. It looks to be moving pretty quickly to me. Not super fast, but not super slow either. Again, totally usable. Don't count these cards out for VRAM per dollar. But also remember they need fans and they also suck a bit of power. So just remember there's always trade-offs where they're going. But if you can get these cheap, and you want a small inference rig to build off of them, you certainly can. We'll wait for this first one to finish up. Gemma 2 also pretty good at explaining its steps and what it was doing. Looking pretty good, using about 43.4 gigabytes of VRAM for it. And the first one back at 6.5 tokens per second. Let's zip right through this. And finishing off at about 4.867 tokens per second. So just under 5 tokens per second on Gemma 2. Let's go ahead and produce that report. And then we'll gather up all of these different reports. Let me expand my screen out. Let's go over to my report management page. We're going to choose all 4 of those tests that we just ran. So the Llama 3, the QwQ, the Gemma 2, and the Mistral 7B, and we are going to combine these all into one report so that we can see it as a comparison. Call it dual M40. And let's hop over and take a look at this report. Go pull it down to the dual M40 report. Sorry, moving a bit slow for the holidays. I think everyone can understand. Alright, so in blue we have the Llama 370B IQ4. In orange is the QwQ at a QA quant. Green is the Gemma 2 27B. And in red is Mistral 7B at QA quant. Definitely see Llama 3 being the slowest. This is the evaluation time. Total time is going to be the first 2 put together. Prompt tokens evaluated. You can see the different tokenizer in between the different models and how they were actually different tokens. Completion tokens, going to be those 2, or this is going to mimic the length of your response. The total tokens is going to be those 2 put together. Prompt tokens per second. You can see that Mistral 7B, of course, was much faster than the other ones. And look at that, QwQ and Gemma 2 are pretty much right near each other. And what everyone wants, the evaluation tokens per second. We have Mistral 7B up there at about 16 tokens per second. The Gemma 2 27B at about 6 tokens per second. The QwQ at under 5, and of course the Llama 3.3 70B at about 2.5 tokens per second. Just a reminder, you can always come to RoboTF.ai, see these different reports. I'll go ahead and throw these ones up there. You can see the current leader report. You can view the different testing reports like this one that are not part of the leader report and see what we just went through and look at the data yourselves. Let's go ahead and take a look and hop over now, and I'm going to satisfy you guys, which I haven't really ever done on this channel, but this is QwFi running with those 2 M40s. Now it's only going to use a single M40 for what we're doing today. This is a Stable Diffusion 3 medium, just a quick, simple test. We're going to use the default prompt. We're going to set this up in Q. You can see the logs down below. The Stable Diffusion model that we're using is about 15.8 gigabytes flat file. And you can make these work on the M40s without a problem. So let's go ahead and get this started, and then I'm going to kick this into fast forward mode because this is going to take just a little bit to generate this image. Alright, 334 seconds later, we get this back. Not bad, did a great job, but 334 seconds later. Let's go ahead and restart this, and then I'll give you guys a good view of about using, LTX, and we'll do some text to video and see how long that takes to generate a small clip. This is, again, just a basic LTX video. We're going to use a default prompt that comes with this one too. You can see the load clip model that we're using there. The base, okay, it was reconnecting on me. And then the LTX video model up there. Should be pretty basic. We're doing 768 by 512, length of about 97, so it'll be just a little bit of a short clip. But any Stable Diffusion is going to really work those video cards. So let's go ahead and get this one kicked in. 699 seconds later, we get this clip. 699 seconds later. Not too bad again, though. Remember, these M40s are old, from 2015, and yet they can still be used for all of this stuff. If you like these type of wacko videos of hacking hardware into other old hardware, give me a like and a subscribe down there. I hope you guys enjoyed this. We've got some more hardware videos coming on the way, and just remember, buy your AI a pizza, and I'll see you guys next time.